Hey everyone. Our project is simulation of swarms of unmanned ground vehicles, uh, specifically using Rasta Swarm, and we'll talk about that here in a second. I'm Carter Nichols. I'm the team leader. I'm majoring in electrical engineering.
I'm Chase. I'm majoring in electrical engineering.
I'm Charles LaFleur. I'm majoring in electrical engineering.
I'm Jesse McDonald. I'm majoring in computer science.
I'm Jefferson Charles. I'm majoring in computer engineering.
All right. So, a quick overview of our project is that drones, and specifically swarming of drones working together, is becoming more and more popularized. And the difficulty of them is first creating software that is cross-compatible with other hardware versions of robots or even software versions of robots, because some robots are only compatible with specific software. And so ROS and ROS 2 focus on combating that and making a cross-platform software. And then we're taking it a step further by using a ROS to Swarm package to do the swarming of robots that is capable of being across multiple different kinds of robots. For example, the Turtlebot, the Jackal, and the Dingobots, right? And so on this diagram here, we can see kind of an overview of how our system will look. So we'll have our host computer, which will host ROS2, and it'll also host ROS1 if the robot we're working with is only capable of using ROS1, right? And so our host computer communicates to the robots, in this case the Turtlebot, over a common network. And in our DaVinci lab, there is a ROS Dingo network that is there.
So the first step in our project was to set up ROS2 Swarm, specifically version 1.2, on Ubuntu. Um, and once we have the full installation of ROS2 Swarm, then we are able to run simulations of the Turtlebots on Gazebo. And once the simulation is running, we can have the Turtlebots performing commands such as aggregation when the Turtlebots come together, or we can have them perform dispersion when the robots disperse, or we can have the robots do random walking. And the next step is to have ROS2 Swarm running on the actual Turtlebots and get the actual Turtlebots to perform the different swarming behaviors.
But before we did that, we need to make sure that the Turtlebots themselves could actually run. So we set up all the Turtlebots, we set the OS, set the packages, and we want to test this through using telop commands that come with the Turtlebot 3 package. We do commands and we give manual commands to the Turtlebots through a keyboard or a Bluetooth controller. It makes the Turtlebots move around. During this time, we were able to find out how to view the topic list of which topics are on the current robot and what data is being published to a topic and such, what's subscribed, what's published. This allows us to see what exactly is being published to the topic. This is great for being able to debug, see what works, what doesn't, what's being sent, and it's incredibly helpful for development.
So next, we were also able to do 2D mapping, which uses a technique called SLAM, which stands for simultaneous localization and mapping. And we basically draw a map by estimating the location of the robot in a space, and then once the slam is up, we will move the turtlebot around with what Jesse was describing earlier, with either a Bluetooth controller or teleop commands from a keyboard on a laptop. And we move it around, and the turtlebot running the slam begins to build the map. And we went through the DaVinci lab in the Engineering East building and mapped it as shown on the right. And the white area is open space, and then the black are walls, and the robot cannot obviously run into the walls, so that's how it represents it. And then once we have all our maps, we're able to navigate from using the robot from move it from one location to another by first estimating its current position in the map, which is kind of what's shown on the right with all the green dots. It's kind of what the LiDAR sees currently, so it's able to estimate where it is. And then we set a goal, and the robot navigates there. And once it's at the end, it's autonomous. As I said, we set the goal and it does it on its own, and also avoids obstacles at the same time.
The future progress that we need to meet in this project would be to officially download the ROS2 swarm packages onto the TurtleBots and begin having them working simultaneously together and doing the steps we've done before, but with multiple robots at the same time. We've begun attempts, but we're running into issues we are currently troubleshooting. These issues include it's not moving, and we can see that data is being published and subscribed to, and we're also able to echo that data, which means there is communication there. The information is being brought up, but it's not doing anything with it. After we were able to do this, we'll begin the movement patterns as described in the project, where they will disperse or aggregate. And we'll also use obstacle avoidance using the hardware protection layer, where it can avoid objects on its own without having to really think about it. And other robots in that swarm will do the same at the same time.